Take it away.
All right. My name is Patrick Jorski. I work for BASF Construction Chemicals. I am the parking and restoration specialist for North Texas. My area is from Waco to Oklahoma border, Wichita Falls, and Louisiana. And the program we're going to talk about today is really successful coating applications to make sure you got a good project and you get a nice appearance. And really, some of the objectives I want to kind of go over today is understanding how coatings work, the difference between coatings and elastomerics, and the ability to specify the correct coating for the proper application and make sure you got, what you want, what the owner wants, and a good-looking project. On the program outline, we're going to assess why protection is needed, site and survey, definitions, common terms, value, current technologies and differences between coatings and paints. This is what you want. All your owners, contractors, GCs, you want a nice, good-looking project when you leave. That's what the owners want. That's what they expect. They don't want this. They don't want delamination. They don't want coating failures. It's no good for anybody. And I go investigate these all the times. Improper prep, too thin, too thick. So there's a lot of different avenues to take into consideration when you're doing a coating project. And work smart. Get what the customer wants. Actually, a lot of these photos you're going to see in here is actually projects I've sold over the years. I've got projects in the Dallas-Fort Worth area that I sold 22 years ago. Still looks great to this day. Maybe a little fade, but you want a good application and you want a good coating for your projects. Why protect substrates? It's not just color and aesthetics. You want some protection to keep moisture out. Mold and mildew, they get inside of buildings. Fungus, and like I said, aesthetics to a certain extent. You want to waterproof it, but aesthetics, you want a good, pleasing, nice project. When we start talking about vapor transmission, every building breathes. Moisture comes in and travels out. So you want a coating that's really breathable for your substrates. If the coating's not breathable, that's when you have blisters and you have failure. So you really take into consideration that all buildings breathe. In the east, moisture goes out, and here it comes in and out. So moisture transmission is a big attribute to doing the right coating. When you start trying to compare different products and the breathability of products, you start talking about perms. When you're talking about wet cup perms means the higher that number is, the more breathable the product. So if you got a wet cup test and the perm is 25, it's a highly breathable product when it's a wet perm test. Now when you go to dry cup test, the lower the number, the better the perm is. That means the more breathable it is. And when you start talking about consideration about perms and how breathable a coating is, if you got a project that's got multi-layers of coatings on it, the more coats you got on there, the less breathable it is. So take that if you're doing a recoat or renovation, that needs to be taken into consideration on the type of coating you want to put on top of it. Coatings are not the answer alone. If it can be a great pinhole-free application, but if the roofing details are not done right, parapet wall's not coated on the backside. I get calls all the time. The coating's leaking. We'll go up there, the parapet wall's wide open, CMU block. Everybody forgot all about it. So all that needs to be taken into consideration. The joint design wasn't done right. The sealants wasn't cut out and properly installed because that's going to let moisture in. So coatings can't fix everything. So everything needs to be enveloped in a tight building. When you start walking projects for restoration, you take a site survey, take in consideration of what's going on, what is causing it, what's causing the cracks, why is the coating failing, why is the ceilings failing. You need to take that all in consideration. Take a look to see if it's a pinhole-free application. I go to projects all the time and they said, well, we put 2 coats on there. Well, they put 2 coats on it, 400 square feet per gallon. It's very, very thin. That's not pinhole-free. Doesn't matter on how many coats, it matters on the total millage of that coating. High build coatings would be about 14 to 16 mils. Paints are usually dried at about 4 or 5. Let's talk a little bit of the difference in your project options. You got water repellent, you got film formers, then you got versus penetrants, you got solvent, and you got waterborne. When we start talking about coatings, you start talking about elastomerics versus non-elastomeric coatings and water-based versus solvent-based material. We start talking about film formers and water repellents. They impart a sheen. They lay up on top. They're a physical bond. They're not a chemical bond. A lot of times when you got film form or water repellents, they'll change the aesthetics of the brick or stone. If you got a light stone and you got a water repellent that's going to part a sheen, a lot of times it turns amber or cast and it has a potential to ghost. Your film form or water repellents doesn't allow moisture to travel in and out. It traps it in there. Now, your characteristics of your penetrating sealants, water repellents is they chemically bond to the substrate. They become part of the substrate. They don't change the appearance when they're applied correctly. They don't change the appearance of the substrate, and they protect that building. They don't break down in UV because they become part of the block. When you start talking about paints, really paints do one thing. They damp proof. That's all they do. They impart color, are usually less than 4 to 5 mils total dry film thickness, little chemical resistant. When you start talking about high build coatings or high build acrylics, you got carbon dioxide diffusion. They protect that substrate. They usually go on 14 to 16 total dry film thickness. A lot of times when you do 2 coats of high build coatings, it's like having extra 9 inches of concrete cover. So it's really protecting that building for what you need done. When you start talking about the difference in testing of high build coating versus paints, a lot of your high build coatings are going to be tested at 100-mile wind driven rain. A lot of your paints are only tested at 60. You start talking about accelerated weathering. When you start talking about high build coatings, we do accelerated weathering tests that kind of represents 14 years of high UV. Most of the paint company stuff you can see 5 years. You start talking about flexibility and impact resistance. You don't really think about that, but look at all the hailstorms we had come through Texas. So you want something that's impact resistant stuff so it doesn't do any damage to the substrate you just finished up. Also, elongation and recovery. A lot of manufacturers make a lot of elastomerics. They'll say 300% elongation, but do they recover? So there's different tests, so take that into consideration, what ASTM test they check their products at. And permeability. If you need a high perm coating that's going to have like a parking garage. One of the projects sold last year, I've got over 30,000 gallons on the Galleria parking garage. I had issues with the coating peeling years ago. Sold them one of our products with a high perm rating that coated it 6 years ago. Still looks great to this day. So we've had no coating issues over there. Because when you have a garage and they want a light reflecting coating in there, water and rain is going to get in there somehow or another. So it's going to travel through that concrete. So you want a highly breathable coating so it doesn't push off. If you had a coating that wasn't breathable, you'd have these blisters all around and pushing sheets of coating off. When you start talking about paints, there's a big difference between painters and waterproofers. Painters can throw it at 350 square feet per gallon. They're usually less expensive, low build system. They're a little bit less expensive. If you got an owner that's going to turn around a building, sell it quick, hey, if you want to go paint, great. But if they got a building they want to keep, protect, and have a long longevity for that building that they want to invest into, look at going to the high build coatings. Your upfront cost is going to cost you a little bit more, but is the building going to last longer? So take that into consideration when you're sitting down and talking to your owners or your customers or any other projects that if they really want it done right, look at the high build coatings. Let's talk about the difference between high build acrylic coatings and elastomerics. Elastomerics do a great job of flexibility, elongation, and recovery. And their permeability, they're not as permeable as a high build coating. Your drawbacks on elastomerics are really is adhesion. They don't bond as well because they're made to expand and contract, so they're made to slide on each other. And you have a little bit of dirt pickup when you have elastomerics. They don't sheave dirt as well. And when you start talking about non-elastomeric coatings, high build coatings, they're flexible. They have a better adhesion than elastomerics. One of the worst things I see specified on projects for tilt-up panels is elastomeric coatings. Why do you want to put elastomeric coatings on something that's going to expand and contract? Once you get moisture behind an elastomeric coating, it's not very breathable, it doesn't breathe. That's when you start having problems with it. So that's a lot of times you need to think about going to a high build coating that's got good breathability to it. Now this is an elongation test. It's a bone test to check the elongation plus or minus 300%. When you take a look at the test of some different products that are done, look at the millage that they check the dog bone test. You want it to elongate and it has to rebound back. Like I said, a lot of manufacturers will put 300% elongation, but that means it goes like this, did it rebound back? So take that into consideration when you're checking the prices and difference between elastomeric coatings and other coatings that you're specifying. Perfect example, this is a job tilt wall. They wanted to throw elastomeric on it, and I said, why? Well, we got some small micro cracks. What you can do is actually take and fill in those little cracks here, and then come back and put a breathable, high build coating on top of it. It just works better, they bond better. When you start talking about eaves and stucco, you know, you got cracks are 1/16 to an 1/8. Eaves and stuccos are great for elastomerics, but cast in place, CMU block, things that's not going to move a whole lot, that's when your high build coatings work the best. Think about this when you're talking about coatings and the thickness of it. You can see here, you know, everybody knows concrete and brick, when it's hot, it expands. So it's the joints close. So when it gets cold, it's going to open up. So if you got a thin mill system, only 4 to 5 mils and stuff, it doesn't take much to break that coating and start having failures. Now you start talking about a high build coating and stuff, the joints closed up, and then it's able to elongate over those cracks. So just think of this, the thicker something is, the longer it takes to wear through the product. Perfect example of what I brought up earlier. As you can see here, moisture's getting behind it, CMU block. On this project here, it wasn't pinhole free. They're saying there's something wrong with their coating. I said, no, my coating doesn't have pinholes in it. It's improperly applied. Also this right here, there's actually a little ledge right here. There was no caulking detail, and this AC unit's dripping, and moisture's getting behind it, pushing the coating, you got efflorescence coming out. CMU block, perfect example. You can see where the elastomeric's trying to stay bound and tight. It's not going to glue that building together. But as you see, there should be a caulk joint here. There's no caulk joint there. There should have been a caulk joint to handle the expansion contraction. Like I brought up earlier, eaves and stucco, great application for elastomeric coatings. Because a lot of times, even stucco, when they dry it over time, they have micro cracks in it. They're small and they're made to move. So elastomerics work phenomenal bonding to those. But you never want to see elastomeric wrapped underneath soffits or underneath ceilings, because ceilings and soffits, that's 90% of the time you're going to have dew point, or you're going to have moisture buildup, or a roof leak. And what will happen is your perm ratings on your elastomerics are lower than a high build coating. So when you're doing even soffits, switch to a different product, a high build or high perm, so it doesn't push that coating off. Non-elastomerics acrylic coatings. You know, they can coalesce at lower temperatures. They can handle a higher pH, especially if you got some patching that's done on a job. Your high build coatings and stuff can handle a pH right around 12. A lot of times with patching, I'll come out and do a pH test, but they need to get it done. And so I switch them to high build coatings when that type of application needs to happen. It's got superior adhesion, especially to slicker surfaces. They bond better than your elastomerics do. You know, one thing that's critical, the most critical thing with any type of coating application is surface prep. You know, contaminated substrates, if you're doing a recoat in a building downtown Dallas, you know, exhaust fume is contaminant. So a lot of times you need to take consideration and do a light degrease and clean and light pressure wash. If you're going to be coating a job that's CMU block or split face block, I like to see a very light wash, because you don't want to introduce more. At 3,000 PSI, you can push a hell of a lot of water into CMU block. And you come back and put a coating on it too soon, you just sealed moisture inside that block. So you're going to have some issues. So we like to see a light application. You know, and job mock-ups, make sure everybody's there for the job mock-ups to prove the colors, make sure the aesthetic's going to be adhesion test. You know, it's a get out of jail free card. Get that done before the project starts. You know, proper surface prep, like I said earlier, remove all contaminants, earth, grease, grime, bond breaker, make sure the substrate can take a coating, and then do adhesion testing before the project starts. And one good test to test for porosity is really, I carry around a squirt bottle. I go up to a substrate, especially if it's tilt wall new construction, I'll actually take and wet that substrate. And I want to see that moisture suck in. Same thing I do with deck coatings also. When a guy's prepped that substrate for deck coating, I'll put water down, I want to see it soak in. If I see that water bead up or not penetrate in, you know you're going to have issues with the coating bonding to it. It's a quick, easy test to make sure you got good adhesion. You want that to wick in so it can accept that coating. Here's an example of a project I sold a couple of years ago. Painter was getting ready to go, and I said, no, you're not. All this yellow stuff you see right here is bond breaker. And concrete told him that concrete guy said it was going to break down a UV. Well, for 2 weeks we had rain, no UV to break it down. A lot of times the stuff, a pressure washer won't get that stuff off. There's times and stuff that you actually have to sandblast those substrate stuff so that that coating's got a good bond, a good substrate to stick to. Example of a recoat job. I had a project years ago. It's a recoat, old downtown building. They washed it once, and I always just take your hand and rub across it again. And it was like talcum powder. So if you paint a substrate it's like talcum powder, that coating you can pull it off in sheets. So a lot of times I'll have them prep it again, take a chalky surface primer, something to lock that down so you got something that the coating is going to bond to. Also, if you take a look at this wall here, this panel is slick. You can actually see the guy's reflection in there. There is no way anybody's coating is going to stick to that wall. When something's polished that clean, that's nice. They actually have to come back and sandblast that to make sure they got a good profile to get the coating to stick to it. You know, I always get asked, you know, I did the repairs, how quick can I throw the coating over the top of it? Well, there's one easy way to do it. You want the repair to actually have at least 80% of its strength before you throw a coating over the top of it. If it is a deep repair, if it's 4 to 3 inches stuff, it's going to take a little bit longer. And there's one thing you can do to bring down that pH on projects is vinegar. You can actually take vinegar and water and stuff, put on top of that light acid, will bring down that pH of that patch, so you can come back with a coating. High build coatings can usually handle pHs right around 12. There's an easy way to do it with a pH pencil or with litmus paper to show how hot that pH is. Also, when you're coming over joint sealants and stuff, if you've got tilt-up panels, I would like to have the guy that's going to be doing the caulking, I like to have him pick a color that's close to the coating instead, so when the coating comes over the top, if it does flake off a little bit, you don't see it. I said the get out of jail free card. You know, field mock-ups, pre-application meetings, and bond tests to make sure that the coating that you put on there is going to bond to the substrate that's going on. Also with the mock-ups too, you know, get the systems together, put them together. If it's a textured or smooth, make sure they put the mock-ups of the coating that they can put up there. Make sure they sign off on the colors. I mean, there's nothing worse than you start doing a building and the owner says, I want this color, they have a color chip. Well, color chips are small. When you compare it to a bigger sample, the color chip is always going to look darker. So I always like to make them do a big mock-up on that project and have a color card too, and have that owner or architect or somebody sign off on it. This is what we approve, and you hang on to it, or leave that mock-up for that whole project so you've got something to compare against. Also, ASTM test. It's the D3359. I do this a lot. Actually, there's a special tape that you can actually get, but I use duct tape. I want something that's going to bond real tight and real hard to it. As you can see, this was a previous coated job. They wanted to come back and throw coatings over the top and said, let me check it. Went over here. This all pulled off. And actually what you do to do your ASTM test, you actually take a razor, you cut it into a square, you take the tape, push it flush. I like to take an eraser to get any bubbles or anything so it's tight and pull of it. As you can see, this was a pass. This was a major fail. So if you're going to do a recoat on a job, you need to check that previous coating too to make sure it's tight. You know, I get called all the time, can I warranty my coating going over pre-existing coating? I said, I will warranty my coating, but I'm not warranting the existing one. If that previous coating comes off, you can't blame my coating for it. So take that into consideration when you guys are doing some recoats. You know, attendees, when you're having your meetings, you know, make sure to get specified the GC, the applicator, and if possible and stuff, make sure you get the manufacturer's rep out there. So if there's any questions that need to be answered, everybody's on the same page and knows what is suspected. You know, the meeting agenda, you know, verify the prep, make sure good, clean, sound, dry, inspect, you know, approvals through it, have, you know, when the job starts up, have another meeting, check the progress and check the millages of the coatings. What are common problems in coating applications? This job right here, you know, years and years ago, everybody loved to throw alkyd paint on everything, thought it was a fix to make sure the buildings last. One thing's about alkyd coatings and stuff, they don't breathe. They have no flexibility. And if you want to recoat this job, all this stuff's got to come off. And what happens too, if you got an old building too and you got multi layers of coating and you want to recoat it, what happens, you can have intercoat delamination, where it's not the coating that comes on top of it, that last coating you throw on it could break the straw. So take that into consideration, do pull tests. Sometimes, you know, you got to tell the owner straight up, we're going to have to remove this old coating. It, you know, might have lead in it, or it's just so bad it just finally broke down and turned to powder. Too often people cause problems. You know, everybody's got a strict deadline that they got to meet to get this building opened up. And when you start pushing, you're going to have some applications where you had rain on there, or you know, you have dust storms that blow through, or you know, commitments and stuff to get this thing done. You know, give the coatings as much time as you can to cure and prep to make sure you got a good product. Because the last thing you want to see is have to do a building twice. No one wants to see that done. You know, blisters. You know, when we start getting the cooler weathers, we have a problem here called a surfactant leaching. What will happen is during the dew point early in the morning, and they'll throw a coating on top of it, and you get these little streaks inside there. What happens is that moisture reacts with the acrylic inside there, called surfactant leaching. I'll send you a little sample around what happens when you get rain on it. You get these shiny little streaks in there. It is very difficult to fix. It happens right around the cooler months. So if you got a project, you know some rainstorms are coming through, make sure those guys shut down. Because like I said, you got to at least have about 12 to 18 hours. Usually I like to see 24 hours of that coating drying before any rain is going to happen. You know, we start talking about color fade and the issues with color fade over time. There's a thing called organic pigments. Organic pigments are colorants that are used for like a real bright yellows or magentas or blues. They're going to fade quicker. Even the darker the color and stuff, they're going to fade quicker. If you use inorganic colorants, which we try to formulate in our products so that you get the most UV stability of the product, you don't want to see a product fade in 2 years. If I got an owner and stuff that wants me to give a warranty on a deep red color, always let them know you got the potential for fade, because reds, blues, purples, and they got so much color in it, they have a tendency to fade more because they absorb a lot more heat. You know, texture affects color. If you take a look at this field they didn't change the grass, they just mowed it different. They mowed one way this way, one way that way, so color affects the color that looks. If you take a look at these two samples here, this one doesn't have any texture in it, this one does. That's the only difference between the two, is the texture. Another example, we had a contractor and stuff that had to do some rework on some panels, came back in and shot it, and he goes, color's off. Well, it wasn't the color. This to the side had 3 times more texture than this. They did a real light application here and had it heavy on the side. He goes, well, how are we going to fix it? I said, you better throw more material on there. As you can see, if you go up there and take a look at it real close, it's the same color. This one just has more texture than this. Just like acoustic on a ceiling. If you ever had a leak in your ceiling at your old house and stuff with acoustic, you know, that guy come in there and do that patch sticks out like a sore thumb trying to get it to blend in. Same thing with high build coatings. If it's got a texture to it, the guy's got to take in consideration that he's going to do it right. You know, zebra striping, I love getting called, why's your coating streaking? There's no streaking in the bucket. It's the way they put it on. The coating's going to go on how it's put on. And to eliminate this problem, when I do my training classes with my guys in the field, is that all coatings and stuff, you want to tip off in one direction. So say this is the wall right here, and they're loading up that wall. They want to load up the material up that wall, and then on the finished coat, they want to bring everything down in a downward stroke. I like to see 2 guys in a basket that can do a roll job. One loading up, one coming back and finishing everything down in downward stroke. And the reason why you want to finish in a downward stroke is you want that stipple to be coming down. So when water hits that building, it sheaves water better and it doesn't pick up dirt. Time and time again, I'll go in there and see this zebra striping coming through this job. I actually did some samples here to kind of get you a better picture of what zebra striping here. I took the roller and went up, down, up, down. And when you look at a big slick building, it actually looks horrible and it's hard to fix after that's already happened. So you see a project and you see them just rolling, going like crazy, stop them, tip everything off one direction, you want to tip it down. Slide that around. You know, roller marks and lap marks. That's guys being lazy and stuff. They need to overlap that roller. So when they're doing that wall and tipping it off, they want to take and make sure they don't stop just right at that edge where you got that buildup. They need to come over and lightly lap over a little bit to pull those lines out and stuff, so it's got a nice clean appearance to that building. Also temperature. If it's really hot, they shouldn't be coating the building. I've had a project with GDA not too long ago, and we're going to do it at night, and it was 7:30 at night. I went and ran a temperature gun on that wall, and it was 150 degrees still. That's too hot to throw a coating on it, because what happens, it doesn't let it coalesce. it makes it where you get these little craters in it, so they need to take that into consideration when doing wall coating jobs. Do it in the shade or schedule it to do it at night, but when a building's really hot and stuff, coating doesn't stick as well. Same thing when it's really cold. Sometimes you have to go to a solvent-based material, but it's so cold, the coating won't coalesce and it won't bond as well. Pinholes. You know what, when we're doing CMU block walls, we like to see a block filler go on there first. Because, you know, like I said, if it's got pinholes in there, it's going to allow moisture to get in and get it behind the building. And a lot of times you get moisture inside a building, that's when you have mold and mildew start happening. Efflorescence. You know, efflorescence, the buildup of salts. You know, it's moisture inside the building being drawn out. You know, you can't fix it right off the bat. What you need to do when you're doing a new building like CMU block, you need to be patient. Every building's going to go through an efflorescence bloom. It's always going to happen. The salt's going to come out of there. So if you can, give that building some time for those salts to come out of that wall before you coat it. Never try to clean efflorescence with water. All you're doing is injecting more and more water in that substrate. You're just going to cause more and more salts to come out. So if you're going to do that, you know, use a light efflorescence cleaner and very low water, very light water on there and stuff. You don't want to induce a whole bunch of moisture inside the walls and cause more of a problem for you. You know, how to really ensure that you got a quality job. You know, make sure everybody's in pre-installation meetings, you know, mock-ups. Make sure everybody comes to the mock-ups and the samples. They've signed off on the colors. Make sure the owner of the building's there. This is the color you want. Don't just have a small swatch. Get the true coating and put it up on that wall. Make sure they sign off on it. And make sure they give it time to cure. Because when you put a coating on top of a wall, it's going to go on dark and dry light. So don't let them come up there and they put it up, yep, that's what we want, and then they come in the next day, it's totally different color. So give the coating time. You know, make sure the temperature restrictions and the coverage rates. You know, when you're talking about high build coatings, you're looking at going on about 80 to 100 square feet per gallon. You know, and one way to really check that is with a wet mill gauge. So if you've got a product that's basically 50% solids and they put it on it and it goes on at 20 mils wet, it's going to dry at about 10 mils dry. And you can only use wet mill gauges on smooth substrates. There's no way to check it on a real rough substrate and stuff to see if you got the proper millage. What you have to do is do a takeoff. Figure up 100 square feet. A gallon should go about 100 square feet down one substrate. Now if it's real rough, you need to take that down because you need to take into consideration the corrugation and everything to it. So figure that area about 60 square feet. So have the mock-ups, make sure the mock-ups, check them how far they're getting per square foot to make sure you got the proper coverage rates. Remember, all coating's not the same. Paint is not a coating. Paint's all they do. The most they do is damp proof. You know, you want to protect the concrete and substrates around you. You know, conduct site surveys. You know, beginning of the project, maybe halfway through. You know, do site, you know, mock-up tests. Leave those samples up there so everybody understands what the project owners want and what they need. So keep those there. And I appreciate you guys' time. It wasn't too bad, was it? Didn't put anybody to sleep. But if you guys got any questions, I'm here to answer anything you guys have.
I have a question.
Yeah.
You mentioned checking the mills on substrates. Would OSB consider a rough substrate pretty smooth?
OSB is pretty smooth, so you can check it on OSB. That's a real easy test. And actually what I've got here too is I can get copies for you. Kind of some letters I put together like maintenance cleaning of high build coatings, how to do it. They can be washed. You just can't bear down on the wall with, you got 3,000 PSI, you can blow a hole through concrete. So they need to really lightly wash it, clean them up with a light solution. Also on Rylam tube testing, you know, I do Rylam tube test on projects when we do a mock-up and make sure it's waterproof. It's an easy application and make sure everybody's on the same page. You can also do that with your water repellents also. I highly recommend that. If you're going to check the water repellency of a job, especially on split-base block, you know, sometimes the data sheet will say 100 square feet per gallon. I've had project stuff, we had to take it down to 60 where they had to double coat it because it was so porous and so dry. Also, I've got it here on a little bit of information on like surfactant leaking, if you guys want a copy. What that is, it's when you have high dew point and it actually turns that coating into a soapy film, and it's very difficult to fix because you can't throw more coatings over it because what happens, that'll just come back through. And then, like I said, what film thickness procedures and applications for it, how to really properly check it. Yes, sir.
You mentioned not putting the elastomeric coatings on the soffit section.
Yep, underneath that sofa.
Okay, if you were on just say a precast panel where the return was maybe 4 or 5 inches.
That's okay. That's okay. If the return's real small, something like that,
Right.
that's fine. It's really when you start getting back about 6 to really 10 inches,
Yeah.
that's when you start getting condensation and buildup right there. That's when you want that breathable product.
Can you use a wet film gauge on the coating that's cured?
No. I got into it with a consultant one time, and he's sitting there pushing it too and sending me pictures of it. I said, "You got to be kidding me." I said, "The only way you can really do it is there is a not a tooth gauge. I'm trying to think if you actually cut into it, look through a little small microscope. Actually, what I do, I keep a caliper inside my vehicle. I'll take and cut it till I get to that substrate, get in there and take it and measure with that caliper to make sure we got the millage. I'll randomly check it through there. But like I said, it's really hard to check that when you're on a rough substrate. Really, the main thing is that coating's got to be pinhole free. You know, if you got a rough substrate, the data guide might say 100 square feet, you can probably take it down to 60 square feet per gallon. Any other questions? Yes, sir.
Say you have an old building, CMU, undetermined number of coatings.
Yep.
It's settled a lot, so you have a lot of cracks.
Mhm.
What would you suggest for prepping that wall? I have no idea how many coats are on it.
Okay. What I would do, you need to grout out and seal those cracks. You can do it with a sealant, or you can take and do it with we got crack fillers before the application of the coating. And what I would do, if they're just aesthetics is what they're looking for, one thing you need to find out too, if it's got elastomeric on there or not. And one way to tell if it's got elastomeric on there is actually take and get a piece of that coating and pull it and stretch it. If it's really highly flexible and you pull it and it rebounds back, that's elastomeric. You need to go back with elastomeric coatings back over the top of it. If it's just like a paint or multi-layers of paint, I would go something with a high perm rating, a high breathable product, because you don't want to seal that moisture in there and be the last straw that breaks the camel's back on that. I can talk to you about our different coatings and different coatings that are out there, give you some recommendations. I always like to go out and see projects too. If I can be of any help, you guys got questions, I'm local. There's a guy like me in every state, in every, we got two people down in Houston. We got a gentleman in Oklahoma. We're here to help you. So get us involved in stuff. We can help you with recommendations on some of the projects. Any other questions?
What are you doing tomorrow?
I'm actually going to Temple tomorrow. I actually go to look at a project down in Temple. Like I said, I'm usually around here quite often. I love doing presentations like this. Coatings is kind of one of my passions. I've been selling for a long time. I enjoy talking to people about it and the applications, how to do a job right. Because everybody wants their buildings to look nice, not just aesthetically alone, but you really want to protect buildings. Because, like I said, I've got some projects here in the Texas market. I was a third distributor 22 years ago. That to this day, they still look great. Maybe a little bit of fade, but I don't see any peelings. I don't even see any coatings coming off.
So on any recoating job, whatever you're going over, maybe besides determining what it is and the power washing or cleaning the substrate,
Yeah.
should be standard procedure.
90% of the time, yes, 100%. Lightly wash, don't bear down into it, especially if it's split face fog. Lightly wash it, and then take your hand and run it down and do an adhesion test. Number one, you want to do an adhesion test to make sure that previous coating was tight, because you're counting on someone else's prep work when you're going over a coated job. I've gone up to jobs before, everything looked great, took and did the ASTM test with the tape, and sheets of this stuff coming off. When they started lightly washing that building, stuff started blowing off like crazy. And, so the owner was kind of getting upset about it and said, "You're lucky you caught it now before they coated the whole thing, because, I warranty my coating, but I don't warranty the existing coating. As long as that existing coating's tight, there's no issues with warranties. So that really has to be checked. So when you're doing something like, especially if it's a high-profile job, get one of us involved with it, and let's check it out, make sure that everybody's on the same page and what the owner expects. If they're just wanting a color coat, great. We got coatings for that, low build systems. But if they're wanting to keep that building and make it last a long time, yeah, we got coatings that work phenomenal.
You're saying pressure only?
Light pressure wash. Sometimes you can take light cleaners and stuff on it, because especially in downtown Dallas and stuff, you get all the exhaust. That gets into the coating, all the exhaust fumes and everything, the oiling. So you can do a light solution of it, like a light degreaser, like 1 part light degreaser to like 10 to 15 parts water, just to kind of loosen up so it washes off real easy. There's a bunch of special cleaners that are out there now to help lightly clean it, but don't bear down. We like to see a very, very light wash. Not pushing a whole bunch of material in it, because you actually cause more damage. Any other questions? Well, I've got some brochures on some of our coatings up here. If you guys want copies of some of these tests, I can make you some copies to give to you so you can put them in your binders and help answer some questions. But I got my business cards up here. If you guys ever need anything, feel free to give me a call. I appreciate you guys' time and